look at the 173 Chapter 7 sample test. Now I'm asking you to choose to do each of these 5 different methods on each of them on one of these at least. So I think this one, U substitution would leave a 2x, which nothing to cancel it. So I'd probably not do substitution. It doesn't look like parts. It doesn't look like partial fractions, but I think a trig substitution on this one might work. And this is like a squared minus x squared. That would be a sign substitution. A would be the square root of 5, and so we'd let x equal square root of 5 sine theta. That would be the start of that one. So I'm going to leave that one and leave that as a trig substitution. This one, if we let u be this, the derivative would be 3x squared. And I think the x squareds would cancel. I think this would be just a pretty simple substitution problem. I would let u equal 3 minus x to the third. And then du would be minus 3x squared dx, and du over minus 3x squared would be the replacement for dx, and the x squareds would cancel. I get a minus a third out there. So it looks like that one would be pretty good for that. This one reminds me a lot of partial fractions. And no factor is repeated. They're all linear, so I don't have to do bx plus c or ax plus b or anything like that. So I think this might turn into 2 to 3 of something over the x plus another constant over x plus 1 plus another constant over x plus 2. Now you have to remember the rules. If one of these was squared, you'd have a single and a double dx. And so then we'd have to go through and find the a, b, and c and integrate. So this one looks like partial fractions to me. This one, I think we got a couple ways to go on this one. Since there's an odd power, we could go with substitution. Now this wouldn't be a trig substitution. This would be a substitution of a trig, but not the trig substitution where we do looking for a squared minus x squared or a squared plus x squared or x squared minus a squared. I think this would be a nice easy substitution, but we've already kind of chosen that, so maybe we would want to use the tables and do a reduction formula to maybe get a handle on that one, so I can show how I can do the tables on that. Now, we might try integration by parts, but that doesn't work very well on something like this. And we haven't selected integration by parts, so I'm guessing we're going to do integration by parts on this one. And in fact, if I let's see, I'm not sure how to integrate ln, so I would probably let u be ln of 2x and dv to be x to the fourth dx. And this would be the d row. So, all right, so let's go through and do these. Okay, so the first one was the integral dx over the square root of 5 minus x squared. Already said that we'd let x equal the square root of 5 sine x. Draw the triangle. And the sine is x opposite over hypotenuse. So this side would become square root of 5 squared, which is 5 minus x squared. And so this quantity would be square root of 5 minus x squared over square root of 5 would be the cosine of theta, adjacent over hypotenuse. So the square root of 5 could be put there. And theta. And so dx would equal square root of 5. Derivative of sine is cosine theta d theta. So this integral would become, the dx would be replaced with square root of 5 cosine theta d theta. This square root thing would be square root of 5 cosine theta. These would cancel, and so we'd get integral of d theta, which is simply theta plus c. But now we have to go back to x's, so if we divide by the square root of 5 and then took inverse sine, we'd get sine inverse of x over the square root of 5 plus c. Okay. So that's the first one. The second one was the integral of x squared cosine of 3 minus x cubed. And I said simple substitution on this one. If we let u equal 3 minus x to the third, excuse me, then du would equal negative 3x squared dx. And so dx would be du over minus 3x squared. So this would become the integral x squared cosine of u, and du is, dx is going to be du, and the x squareds are going to cancel. So we're going to get minus 1/3 the integral of cosine u du, and the integral of cosine of u is sine of u. Derivative of sine is cosine. And so then we got to go back to x's. So this would be minus 1/3 sine of the quantity 3 minus x to the third plus c. All right, the third one, partial fractions. So we had the integral of 2x squared minus 1 dx over x plus 1, x plus 2. So that would equal the integral of a over x plus b over x plus 1 plus c over x plus 2 dx. So this one would have to be multiplied by those two. That would be x squared plus 2x plus 1x plus 3x plus 2. This one would have to be multiplied by x and x plus 2, so that'd be x squared plus 2x. And this one would have to be multiplied by those two, which would be x squared plus 1x. We have 2x squared, so if I look at the x squareds, I have 2 would have to equal a x squareds plus b x squareds plus c x squareds. All of them have an x squared in it. Look at the x's. There's none in this, and so 3a plus 2b plus c would have to be 0. And then we look at the constants, and it's -1 on this one equals, see, this would be 2a, no constants there, no constants there. All right, that's telling us that a has to be, get up here where you can see it, a has to be -1/2. That's the case. This equation becomes, put a -1/2 in there and add it to here, so 2.5 would equal b plus c. And if I put a half in here, -1/2, that'd be -3/2. So if I add it to the other side, it'd be 3/2 equals 2b plus c. And these are the same, so if I multiplied one of these by a -1 and added them, the c's would cancel out. I'd get -b equals, so this is 5/2 minus 3/2 is 1. So b would have to be -1. And if a plus b plus c is 2, and b is -1, so that's -1.5. To get up to be 2, c would have to be 3.1/2. Now we can check that. We got c using this one, so we would check here. We said b was -1, so this would be -1.5 minus 2, which would be -3.5, plus 3.5 is 0, and -1.5 times 2 is -1. So it looks like those work, and so our problem becomes the integral. Does this have limits on it? Oh yes, it did, from 2 to 3. It would become the integral from 2 to 3 of -1/2 of 1 over x minus 1, b is -1, integral of from 2 to 3 of 1 over x plus 1 dx, plus 3.1/2, taking the constant out of this one, integral from 2 to 3 of 1 over x plus 2 dx. So we got -1/2. This would be ln x, evaluated from 2 to 3, minus ln of x plus 1, evaluated from 2 to 3, plus 3.1/2 times ln of x plus 2, evaluated from 2 to 3, which would equal -1/2 ln 3 minus ln 2 minus ln 4 minus ln 3. Those are both positive. Those are positive, so I don't have to keep those absolute values. Plus 3.5 ln 5 minus ln 4. And just to clean it up a little bit, ln, when they're subtracted, that's just the division, so that's ln of 3 halves minus ln of 4 thirds plus 3.5 ln of 5 fourths. Okay, so that's 1, 2, 3 of them. Let's go to the fourth one here. So that was, the fourth one was the integral from 0 to pi over 2 of sine squared x cosine cubed x dx. This is an odd power, so the easiest on this one would be to do the split this out to cosine squared x and then cosine x. But let's, since we need to use the table someplace, I'm going to do the reduction formula for this, and let's just take the, let's take the cosine down to 1, from 3 to 1. So this would be the integral from 0 to, reduction formula. So I'm going to let this be m and n, and I'm going to use formula number, reducing the cosine is the formula number 7. And so this will be, the sine goes up 1. So this would be sine to the third x. And the cosine goes down 1. Make sure I get the right one here. Yep. So this would be down cosine squared x over these two added. So 2 plus 3 is 5. Plus n minus 1. So that'd be 3 minus 1, 2 over m plus n, which is 5. The integral of, so the sine is staying squared, because we're not doing the reduce the sine, we're doing the cosine reduce, cosine x dx. So far I've showed that I can do reduction formulas. So that's all I need to do. Now I can go ahead and do a substitution to do this. You just have to show you can do the reduction formula at least once. So there we got this, and this is still evaluated from 0 to pi over 2. And this looks like the derivative of sine. So if I let u equal the sine of x, du would equal cosine x dx. And so this part, so we got this part that stays the same, sine cubed x cosine squared x over 5 plus 2/5. This would become, since I'm doing a substitution, this will have the limits of 0 to pi over 2. Since I'm splitting this, before it had the limits here, this would have been from 0 to pi over 2. This part's going to go to, this is going to be u squared, and cosine x dx is du. So this part would be, and that's from, now we got new limits. If x is 0, sine of 0 is 0. If x is pi over 2, sine of pi over 2 is 1. So this becomes, let's put these in here. Sine of pi over 2 is 1, cubed is 1. Cosine of pi over 2 is 0, squared is 0 over 5, so times 0 over 5, that's going to be 0. Minus, if I put 0 in here, sine of 0 is 0, times cosine would be 1 squared over 5. So out of this, I get nothing. Plus 2/5, and u squared integrated is u to the third over 3. Evaluated from 0 to 1. So I've got 0 plus 1 in here would be 2/15 minus, and if I put 0 in there, I get 0, so I get 2/15. Okay, these definite integrals, you can type these into the calculator and it'll give you these answers too. So you can check and see if you've made any arithmetic errors in doing them. Okay, so now the last one here, the last one of these 5, and it says the integral of x to the 4th ln to x dx. And we decided to do this one by parts, and we decided to let u be the ln of 2x, and v to be x to the 4th dx. Integrating that, that'd be x to the 5th over 5. Differentiating that, that'd be 1 over 2x times the derivative of the inside here, which would be 2 dx. This is the derivative row and the function regular. So this becomes uv, which is x to the 5th over 5 ln 2x minus the integral of this. So I've got 1/2. Well, let's just put it all in there, and then we'll figure out what we got. So we got, actually the 2's cancel here, so we got dx over x times x to the 5th over 5. So we got x to the 5th over 5 ln 2x minus, the 5 would come out. One of the x's would cancel and be a 4. So I got the integral of x to the 4th dx, which is x to the 5th over 5, plus c. So I've got x to the 5th in both of these, over 5 in both of them. And so I'd have ln of 2x minus 1/5 plus c.